All right, it took me a while to get the screen up. Want to do some unit circle work? I feel like this is a crowded board, but I think it will be helpful to at least hear some of these comments about the cosine function and the sine function. All right, so I'm saying cosine first. Normally people say sine and cosine, but really cosine is about the width in a unit circle and sine are about the heights and widths, horizontal, x's, vertical, y's. So I'm going to say cosine sine. All right, so it's important to understand what is inside this parentheses is an angle. Right, and again, it might be confusing because x, we think of x as a distance on a horizontal line, but this variable, x meaning something in Arabic, is referring to angles. All right, and we've got two language systems that we've been talking about. Degrees, I've decided to put the first 90 degrees of non-calculator ratios in a table. You're familiar with degrees. We got to get equally familiar with the other language system, radius lengths, or what are called radians. All right, there are about 6.28 radius lengths in every circle. And so that can be used as a, 60 degrees here, turn it on its side, it's 30, and 30 is 180 divided by 6. All right, so 3.14 divided by 6 is about 0.52. All right, so a little more than half a radius length. If this is a radius length from here to here, then half of that distance, starting from here, might be about here, and then we're going to construct a 30-degree triangle. I'm just trying to get up and running here. It's not the first time you've heard this. So the unit circle works a little bit different than standard definition of cosine is adjacent over hypotenuse. And if we shrink that triangle, the angle doesn't change. And we divide by 5 to get 1, right? We divide each number by 5. So this is 1/5 the size of that. I know it doesn't look it, but this is unit circle work, right? And so the ratios never get bigger than 1, and they never get greater than -1. That's awkward notation, I think. Our ratios are between -1 and 1. Okay, so it's a little awkward the way I stated that, but I think that's a little better. And what we're going to practice is getting the language of trig up to speed for us. And I'm not going to do it in degrees. I'm going to do it in radius lengths. Maybe I'll do it both. I don't know. Right? But we want to do some calculations. And then I'll either make another video, depending on how long this one is, where we look at sine and cosine curves with a couple of points, usually middle or max or mins, and how we write the equation of those pictures that we see. All right, so here's a snapshot. I'll start with the cosine of, I'll give you an angle in degrees. All right, but I'll put it somewhere else in the circle. How about we look at the cosine of 120 degrees? Well, we have to have a frame of reference, and 0 degrees is right there. Straight up is 90, right? Straight up is 90, so 120 is around here. But I'm going to change that into radian measurement now, because that's what we're going to be working with for the most part. So how do I write 120? Well, it's two 60-degree angles. So 120 degrees would have been presented in radians as 2 pi over 3. Okay, pi over 3, 60 degrees, double it, 120. Okay, and pi is the top half of the circle in terms of circumference in a unit circle. So I'm going to look at the top half. I'm going to divide it up into 3 parts, and good drawings get good answers. So 3 parts. That looks pretty good. Well, I said it was over here and I missed it a little bit. But what do we do with trigonometry? We draw a triangle. We always draw our triangles from the circumference down to the x-axis, and that forms a 90 degree. So we're looking at 120, but right now we're going to use this reference angle, which we know is 60 degrees. We've looked at the ratios, 60-degree triangles. How did we do it? It's worth doing again. Yeah, this has been done in several videos, but let's do it again. Equilateral triangle, all sides are 1 unit long, which means all angles are 60 degrees. Those are all 60 degrees. I am going to cut it in half. That gives me 1/2. And Pythagoras, we've done Pythagoras, gets us √3/2 as our missing side length. And √3/2 is about 0.87. Okay, you gotta have a feeling for the numbers. All right. Now, if we tip this on its side, we end up with a 30-degree angle, right? Which is this one, right? Remember, we cut the 60 in half, so that's 30 degrees. And we get the same ratios. And the smallest side is 1/2. So they sine and cosine basically give us the same calculations, but they're off by about, well, I won't get into that right now. 30, 60, 90s will always give us these ratios. Sometimes they're the height, 1/2, sometimes 1/2 is the width. All right, so in this particular case, we want to pretend there's a unit, a Cartesian coordinate system here. So we start from the origin, that's our 0, 0. And I don't want to draw any more lines in here because they get in the way. But to the right, my width is 1. W equals 1. Straight up, my height is 1. To the left, my width is -1. And straight down, my height is -1. Okay, that's a coordinate system here, but I'm not going to put in the X and Y axis. So what are my values here? Well, it's a good drawing. Hypotenuse is always +1. We're not going to change that. Then this is the √3/2, but this one is -1/2. And the cosine is looking at that width in the unit circle. And that's what we're going to practice. We're going to do 5 or 6 of them. What would the sine of 2π/3 have been? Sine of 2π/3. Well, I hope I didn't have to write that again. Okay, I guess I just needed to put it here. Well, that's √3/2. And if I want to locate that, I'll put the sine function here. And the sine function measures height. And the height over here is 0. Okay, so 0 is here, and then the heights go up in the first 90 degrees. And I come back down to 0 and go back up again. We were in the second quadrant. That's the first quadrant. From here to here's the second. That's the third, and that's the fourth. √3/2 would have been about here. And so that would have been about 120 degrees or 2π/3 radian lengths. Okay, let's try another one. Get some quick drawings here. All right, and then we will take that snapshot. Oh, that's a terrible curve there. Rotator cuff problems. There, that's not too bad. And so whatever snapshots we have here, we're going to put them on the cosine and the sine curve, because you've got to get familiar with these curves the way that you're starting to get familiar with absolute value shape, exponential growth shape. Well, I should have gone this way. That felt good. All right, here we go. Let's try, how about we try the sine of 7π/6. All right, so I got to get rid of this triangle and find out where that is. All right, you got to get familiar with π/6. You know what that is in terms of degrees. That's the first step. We'll convert these to degrees until we don't have to. You know, when we learn in another language, I'm always trying to learn a little Spanish. I'm converting it into English, and I'm told that if I get good at it, I just speak Spanish. That's what we're going to try to do here. But first, we're going to have to match it up with the degrees. 180 divided by 6 is 30 degrees. How many do I want? 7. So the first one, 30 degrees. Well, there's 3 of them in the first 90. That's a pretty good drawing. Not too bad. So therefore, now I got 6 more, right? Top half is 6. Looks like 7's over here. So what do I have to do? From the circumference up to the x-axis, 90 degrees. My reference angle is 30 degrees. I've really traveled 210, and I've got one of these triangles over here. All right, and the smallest side is, I think, that one. But because I'm below the x-axis, that's -1/2. And I think that's what I was looking for, because sine is measuring the height, hypotenuse is still one. Strict definition is opposite the angle divided by the hypotenuse minus 1/2 divided by 1. But we can see that that's the same as just minus 1/2. Now, where would that be on the sine curve? Well, that's 180. 180 is half of a rotation. So this 180 degrees, I went just a little further. I went down halfway. Because we know it bottoms out at -1. And the biggest it gets is +1. So does it seem like that might be 210 degrees? I hope so. Because it is. All right. What would the cosine have been? -√3/2 because I'm to the left of the origin. All right, so that's that one. Let's get rid of the pi/6 reference angle. I still want to have my x-axis in here really because I'm basing things on pi, and that's the top half of the circle. All right, so let's try the cosine of 5pi/3. What will that be? Then we'll put that little snapshot on the cosine ratios. All right, so I got to break it up into 3 parts again. That's pretty good. 1, 2, 3, and I guess I need 6. Yeah, and I'm at the 5th, and we're always starting from here. 1, 2, 3, 4, 5. I'm here. What do? Up 90 degrees to the x-axis. And what's the smallest side of this 30, 60, 90? And pi/3 is a 60-degree reference angle. Well, I think opposite 30 is smaller than opposite 60, and you'll learn something about the law of sines later. That appears to be 1/2, that appears to be -√3/2, and I'm after the sine, I'm after the cosine. That's this one. Okay, now what is this? 60 degrees times 5 is the same as 300 degrees. So I'm going 300 degrees, drawing my triangle. So where would that be on this curve? Well, halfway. This is a height of 1, this is -1, but those are widths. These are widths, which is awkward when you're on the y-axis, which is vertical. And I'm halfway up to 1, right about there maybe, halfway up from here to there. And that is 300 degrees. Okay, what's the bottom? 270, 90, 180, 270. And it's going to take some practice. All right, let's do a sine curve now. Get rid of these triangles, these pieces of the pie. All right, let's try the sine of, how about 23 pi/6? Boy, there's 6 of them up here. So I got to break this up into 3 parts. That's 6. That means that there's, oh, got to get rid of that, 12 all together. Wow, there's 12 pieces in the unit circle, which means that going around once is 12 pi/6, twice is 24 pi/6. So right there is 24 pi/6, and I want 23. I think I'm right here. Draw the perpendicular up. There's a smallest side right here. It sure looks like it's -1/2. And that's what I'm after. That's the sine value, because this is 1 and that's opposite over hypotenuse. So -1/2. Yep. So here's the sine curve. Where's -1/2? If this is -1 as a y value, that's about halfway down. Does it seem like I'm 30 degrees shy of 360? Well, actually, I'm on my second revolution, right? I hope so, because that's what it is. And you want to get familiar with one period of the sine function, and you want to get familiar with one period of the cosine, and you tell me how we make that happen. How do we get familiar with one period of the sine function and one with the cosine? Well, we have to have an initial conversation. And I hope you looked at the other video that I assigned, because that means you're hearing the conversation twice. And I don't know how many times you're going to need to hear the conversation, but in math, 4 is a magic number. You do something 4 days in a row, and there's an awful lot of math concepts that you can learn putting in 2 minutes a day, 4 days in a row. It's just the way it works. All right, so now, what else do I want to say here? Maybe let's do one more. One more rep, and then we're gonna unwrap. We're gonna unwrap the unit circle. We're gonna lay it down flat, and we're gonna see what we can do with that. All right, so let me erase this. Let's erase this. Let's throw a x-axis on there again, and let's just look at the cosine of 4 pi over 3. Right, you're pausing the video. I mean, you're in the habit of doing that, I hope. Okay, so it looks like I'm getting 3 chunks. 3 nice chunks, yeah. And I want the what? 4th. Well, that's 1, 2, 3. I think I'm here. What do I do? Well, this is 0 on the x-axis. This is -1 over here. This is +1 on the x-axis over here. And I am going to draw a triangle. You know what? That looks like a pretty good halfway. And if this is -1 and that's 0, I think we're going to call that -1/2. And that's what I was after. Adjacent, this is the angle, this is the adjacent to hypotenuse side, which translates into that number. Now, where is that on the cosine curve? Appear to be in the 3rd quadrant. This is quadrant 1, this is quadrant 2. I appear to be in the 3rd, which is from here to here, and I'm halfway up. If that's -1, halfway is about here. Okay, and halfway is pi, or 180 degrees. I'm a little more than 180. I am actually, well, that looks like a 60-degree angle. And 180 plus 60 is 240. So in degree speak, that's 240 degrees. And I'm getting a width of -1/2. And that's where that would be positioned on one period. All right, I'm hoping you're a little bit better than you were 2 days ago. Right? Because we haven't done many of these in class. Going to do a lot of them in the second half every day for months. And then I hope that you can maybe say, hey, what's the sine of 25 pi over 6? And you say, oh, that's a half. Because we already did 24, 25, just sine height, half. You want to be able to do those in your head 3 or 4 weeks from now. All right, so now what can we do? We can make another video after this one, in which we pick up from here, and we're going to unwrap that unit circle, have a little fun. Initial fun. Might not be fun for you yet. It's going to be fun for me. All right. Ta-ta.